Okay, Assalamualaikum. So now let's come back to matrices part 2. Okay, so we are on basic operation on matrices. We have done the addition, subtraction, scalar multiplication of two matrices, and a bit of introduction on identity matrix. Okay, so here is the identity matrix. Okay, identity matrices are square matrices. Okay, square matrices means the number of rows and the number of columns are the same. So for example, here we have 2 by 2, and here we have 3 by 3. We can have 4 by 4, 5 by 5, 20 by 20. Okay, and so on. Identity matrix denoted by capital I when multiplied with a matrix A will result in matrix A. Okay, so when we multiply a matrix with an identity or an identity with any matrix, the result will the matrix that matrix again. Okay, so identity matrix, okay, some of its characteristics must always ones in the main diagonal, zeros everywhere else. Okay, multiplication by the identity matrix is commutative. Okay, commutative like just now, AI equals to IA, also known as unit matrix. Okay, example 1. It is given that matrix C and matrix D as that show that matrix D is an identity matrix. Okay, how do we show that matrix D is an identity matrix? Okay, we need to use from the definition here, AI equals to IA equals to A. Okay, if this equation is true, then I is the identity matrix. Okay, if CD equals to DC equals to C, then D is an identity matrix. Okay, we need to prove this one. So let's multiply CD first. So CD equals to -1, 3, 2, 5 times 1, 0, 0, 1. Okay, first row -1 times 1 plus 3 times 0, -1 times 0 plus 3 times 1, 2 times 1 plus 5 times 0, 2 times 0 plus 5 times 1. Okay, so the answer is -1, 3, 2, and 5 equals to matrix C. Yeah. Okay, let's do DC. So DC equals to 1001 times -1, 3, 2, 5. Okay, so -1 times -1 plus 0 times 2, 1 times 3 plus 0 times 5, 0 times -1 plus 1 times 2, 0 times 3 plus 1 times 5. Okay, so we got -1, 3, 2, and 5. Is this matrix C? Yeah. Hence, D is an identity matrix. Okay, we use the definition. Okay, next, explain the meaning of inverse matrix and hence determine the inverse matrix of 2 by 2 matrix. Okay, inverse of a matrix. Okay, when we multiply a matrix by its inverse, we get the identity matrix. Okay, the first matrix times the second matrix equals to the second matrix times the first matrix. We got identity matrix. So that means the first and the second is the inverse of each other. Okay, so A is the inverse of B, B is the inverse of E. Next, the inverse of a matrix can be determined by this formula, the one in the yellow box. Okay, inverse. So inverse of a matrix, the symbol is A inverse. Given that that matrix is matrix A, so the inverse is A inverse. So the A inverse, okay, AD minus BC is the determinant of matrix A. Okay, what does it mean by determinant? The multiplication of the diagonal and the off diagonal. Okay, so the diagonal DA and the off diagonal BC. Okay, so the difference is the determinant. So AD minus BC, the difference is the determinant of matrix A. So the inverse can be determined by this formula. If AD minus BC is equal to 0, then that matrix do not have any inverse. Okay, so example, given that matrix C is blah blah blah, calculate the inverse of matrix C. So we just use the formula 1 over AD minus BC. So matrix A is A, B, C, D. Okay, remember that. So AD minus BC, 2 times negative 2 minus negative 6 times 1. Okay, so 1 over AD minus BC, and then we change the position of the matrix, so it becomes D, A, negative B, negative C. Okay, remember that. Okay, we change the position and we add the negative on the off diagonal. So we just calculate, we just multiply, and here is the C inverse. Okay. Example 2. For each of the following matrices, determine whether the inverse matrix exists. If yes, calculate the inverse matrix. Okay. So determine whether the inverse matrix exists. Exists means AD minus BC does not equals to 0. If AD minus BC is equal to 0, so that matrix does not have any inverse. Okay. AD minus BC equals to 8 minus 8 equals to 0. Okay, so this matrix, matrix A, does not have any inverse. Okay, matrix B, AD minus BC, AD minus BC equals to 3 times 4 minus 5 times 2, 12 minus 10 equals to 2. Okay, so this matrix B got an inverse. So the B inverse is equals to 1 over AD minus BC, 1 over 2 times matrix 4, 3, negative 5, negative 2. Okay. So 4 over 2, 2, negative 5 over 2, negative 1, 3 over 2. So that's the inverse of matrix B. Okay. Are you okay with that? Okay, let's move to how to use the matrix method to solve simultaneous linear equations. Okay. Solving simultaneous linear equations by using matrix methods. First, we must have the simultaneous linear equations, and then we transform the linear equations into matrix form, AX equals to B. Then we use matrix method to get the value of X and Y, given that the X and Y are the unknowns. Okay. Write the simultaneous linear equations below in the form of matrix. Okay, so we take out the coefficient 3, 4, 5, -6. Okay, put them into a bracket. Then the first unknown is x, the second is y. So x, y equals to 12, 7. So that's the linear equations in the form of matrix. Example 4, solve the simultaneous linear equations below using the matrix method. Okay, first we must transform into matrix form. So the coefficient 1, -2, 3, -4, and the variables are x and y equals to 1, 4. Okay, you want to find the values of x and y. So the x, y here equals to, okay, we got to bring this matrix to that side if we are thinking of algebraic, a linear equation, algebraic. Okay, but for matrices we cannot simply bring that matrix to the other side by dividing it. So what do we do is actually we multiply this matrix here, with its inverse. So we will get the identity matrix. Okay, so same goes to the other side. We need to multiply with the inverse of that matrix. So the inverse, 1 over AD minus BC, -4 minus -6, -4, 1, 2, -3. Okay, then the matrix 1, 4. 6 minus 4, 2. Okay, and then we multiply these two matrices. We got -4 times 1 plus 2 times 4, -3 times 1 plus 1 times 4. Okay, so -4 and 1. Okay, equals to 1 over 2 for 1. So we got 2 and 1 over 2. So x is equals to 2, y is equals to 1 over 2. Solve problems involving matrices. Okay. Recap concept rubber produces two camera models K and L. Each camera producer needs to go through two departments, assembling and packaging. The table shows the time for assembling and packaging. For each type of camera, it is given that the assembling department operates for 12 hours a day. 12 hours a day. And the packaging department operates for 9 hours a day. Calculate the number of camera K and camera L produced in a day. Okay, so 12 here, 12 hours, 9 hours. So first we must use the same unit. So 12 hours equals to 12 times 67, 20 minutes. 9 hours equals to 60, 540 minutes. Okay, so it's like 10x plus 10y equals to 720, 5x plus 9y equals to 540. Okay, so 10x plus 10y equals to 720, 5x plus 9y equals to 540. Then transfer it into matrix 10, 10, 5, 9. X, Y equals to 720 and 540. Here 1 over 90 minus 5, 89, 10, negative 10, negative 5. Okay, 720 and 540. So xy. So what happened here actually, when you multiply with its inverse, one over 90 minus 50, 40 of 9, 10, negative 10, negative 5. Actually got identity here. Identity, right? Identity xy. Again 1 over 40. You multiply, you got this one. So the xy is 2745. So for camera key, the number of camera key produced is the number of camera key produced is 27 units in a day. Number of camera L produced is 45 units per day. Okay, so that's all. Thank you.